Hello, my name is Eric and I'm a rising sophomore at Colorado Academy. This is my second milestone for my water treatment system. This is my electrochlorination chlorine-producing unit that uses electrolysis to purify water. The components of a chlorine-producing unit are relatively minimal. There is a 2-inch PVC cap that houses a PVC spacer, 3 gaskets, and 2 electrodes, which are very important. Electrolysis requires 2 electrodes, which are electrical conductors that serve as physical interface for the circuit and provide energy for electrochlorination. These electrodes are titanium mesh, and one is coated with ruthenium oxide and the other is uncoated. I had to handle these with gloves because human oils damage the coating. Next, there is a clear PVC piece in the middle, which allows visible confirmation that electrolysis is happening. Lastly, there is a rubber-reduced coupling with a 2-inch PVC drain cap for filtering big debris and preventing anyone from touching the electrodes. To use the device, a 12-volt DC current and voltage supply must be applied to create and discharge ions. I used a portable battery pack. You must pour a table salt in water solution using a ratio of 1 to 10. I used 15 milliliters of salt and 150 milliliters of water. This is my electrolyte, which is a frequently ion-conducting polymer that contains free ions to carry current throughout the circuit. The purpose of the chlorine-producing unit is to produce a water-purifying solution half as concentrated as bleach. By adding 10 drops of this solution to any gallon of water, I can purify water by killing bacteria and viruses as well as sterilizing contaminants. Electrochlorination is bent on interchanging atoms and ions by the absorption and release of electrons in a temporary circuit. After turning on the battery, I add the electrolyte, and the differences in voltages between the electrodes creates an electric field to strip apart the water and table salt. The electrolyte completes the circuit with its semiconductive free ions. One hydrogen and the chlorine go to the anode, and the other hydrogen, oxygen, and sodium go to the cathode. This results in a chlorine water solution for purification and 2 caustic byproducts, sodium hydroxide and hydrogen. The sodium hydroxide and chlorine solution produced has a long shelf life, but it should be kept in an enclosed container to prevent leakage or disturbance of the solution. If it isn't in a closed container, the chlorine can dissipate and leave you with just salt water. During this project, I encountered 3 problems. The first was that my PVC spacer in the PVC cap was too large. So, I filed it down, increased the size of the slots where the electrode ends are, and filled in the extra space of the slots with amazing goop and crazy glue. My next problem was that titanium is impossible to solder. So, I had to find a way to wrap bare stripped wire around the titanium mesh and solder that. Lastly, the DC battery output cord didn't have 2 places to attach my leads, so I stripped it and made my own output connections. Now that I have my biosand filter and my electrochlorination chlorine-producing unit, I can now purify and treat water with chlorine and a biolayer. Now, I'm going to work on my solar panel to power the electrolysis within the cell.